What is population? It also goes by the name universe. It is the larger group from which some individuals are selected for a study. Okay? Or it is the parent group from which sample, this is the sample, is to be drawn. Okay? Population can be finite and population can be infinite. Group of human beings such as men, students, drug addicts, or of non-human entities such as objects, educational institutions, time units, geographical areas, phenomena, etc. are the different forms of population. So, I think you've heard of census. What is census? Census is the process of examining every member in the population. Okay? So, if there are 1 million people in a population, then census means counting each and every one of them. Okay? But majority of the time, an entire population cannot be examined. It becomes impractical to count every unit in a population because of money, time and resource constraints. Measurements of large numbers of people often affect measurement of quality. Yes, it becomes easier to count 10 people in a population than to count, 100 million or 1 billion. It will affect the quality and it will lead to errors. The usual procedure in these instances is to take a sample from the population. Okay? So this is a diagram of population and sample. Population is the larger group and it is denoted by N, capital N, and sample is the smaller group of people selected from population, and this will be represented by a small n. Now let us look at what sample is. Sample is nothing but a subset of the population that is representative. This is a very important word. Sample should represent the entire population. Okay? Subset of population that is representative of the entire population. To study the characteristics of the population, that means the sample should possess the characteristics of the population. A sample not representative of the population is inadequate for testing because the results cannot be generalized. The whole point of drawing a sample from the population is to form a generalization about the population. If such sample is not representative of the population, then what's the use of taking a sample in the first place, right? So a good example is a small amount of blood taken from a patient can determine whether the patient's sugar level is normal or not. This is so because the small sample of blood is truly representative of the entire blood supply in the body. Now we've learned what population is, what sample is. Then what is sampling? It's very easy. Sampling is the process of selecting sample from the population. A relatively small number of individuals or measures of objects or events is selected and analyzed in order to find out about the entire population from which it is selected. It reduces what? Expenditure. It saves time, energy, permits measurement of greater scope, and produces greater precision and accuracy. What are the characteristics of a good sample? A good sample is an accurate representative of the population. It is time and cost efficient, that is, it is economical. A sample should be proportional to the size of the population, that is, it should be large enough to represent the entire universe properly. So let us say there is a population of 1,000 people. If you select a sample of only 5 people, then that is not sufficient enough to represent the entire population, right? So make sure the sample is proportional to the size of the population. And it is goal-oriented and practical. A sample should provide precise information about the population. Randomly selected. Yes, random selection is very important because it assures true representation, and also there will be no bias. Free from bias. It must possess the least sampling error. Yes, errors do happen when sampling takes place. So what is a sampling error? It is a statistical error that occurs when a researcher does not select a sample that represents the entire population. Now we're looking at the types of sampling. It's very, very important. So pay attention, okay? There are primarily two types of sampling. Probability sampling, non-probability sampling, okay? So probability is also called the random sampling. Non-probability sampling is also called non-random sampling. So under probability sampling, there are 4 types of sampling. Again, under non-probability sampling, there are 4 types of sampling. Okay, so what is probability sampling? Each person in the population has equal, independent, and known chance of being selected. Okay? In case there are 100 elements in a population, every element has 1 by 100 chance of being selected in a sampling exercise. That means, let us say there are 10 people in a population. Then each person has the equal chance of being selected. That is 1 out of 10. Okay? The units of population are not selected at the discretion of the researcher. That means the researcher has no power to decide who gets to be in the sample and who does not get to be in the sample. This is the first type of probability sampling or random sampling. Simple random sampling. Each unit of the population is given an equal chance of being selected. The law of chance is allowed to operate freely in the selection. So some techniques used are tossing a coin, throwing a dice, lottery method, blindfolded method, by using random table or Tippett's table as we call it, used when population size is small and units are identifiable. So this happens to be the easiest and the most simplest type of random sampling. So I've made a diagram for you. This is simple random sampling, which means anyone in the population can get selected for the sample study. Now we have the second type of random sampling, stratified sampling. So in this type of sampling, the entire population is divided into a number of homogeneous groups or classes known as stratas. So that means the entire population is stratified into homogeneous groups or classes, and they are called stratas. Strata means layer. Then a simple random sample is taken from each strata, okay? So you will have to apply the technique of simple random sampling to take sample from each strata. An investigator is interested in securing a particular response that would be representative of undergraduate engineering students. So he might stratify the population into 4 stratas of first year, second year, third year, and fourth year. And then he will take simple random sample from each strata. And that way it ensures a better representation. Okay? I think it's very easy. It is used when population size is small and units are identifiable. So it cannot be applied to a population which is very large. Okay, keep that in mind. So simple random sampling and stratified sampling are for population which is small in size. So here is a diagram of stratified sampling. Each group represents a strata. Okay, strata. And one is selected from each by applying simple random sampling. And thus, the sample is formed. The third type of random sampling is systematic sampling. So what is systematic sampling? It is formed by selecting the first unit at random, and the remaining units in the sample are automatically selected in some predetermined pattern. I know this sounds a bit complicated, but this is very easy. Just wait for the diagram and you will be clear. This method is basically used in such cases where a complete list of the population from which the sample is to be drawn is available. That means there should be a complete list of all the units in the population first. That is very important, and after that you will have to choose the sample from this list. For example, we may choose every third name on the list. So you have decided to pick every third person on the list. Very easy and convenient to use when the population is sufficiently large. So here we have the diagram for systematic sampling. This is the third person that you have chosen. So every third person will be your sample. Okay? It can be the 10th person, every 10th person. It can be every 15th person, or the 20th person, or the 50th, or the 100th. So it is completely up to the researcher to choose which kth unit gets to be selected. So this is the fourth type of random sampling, cluster sampling. So cluster has got to do with the geographical element of the population, okay? If the total area of interest happens to be a big one, okay, let us say it is as big as a country or a continent, a convenient way in which a sample can be drawn is to divide the area into a number of smaller areas, okay? Usually called clusters, with the ultimate sample consisting of all the units in these small areas or clusters. So, the term cluster refers to a natural but heterogeneous intact grouping of the members of the population. You'll understand this with the help of an example. So, in a national level survey, at the first few levels, a few states will be selected. And within the states, a few districts may be selected. And then, within each district, blocks may be selected. And after blocks, come the villages. Okay? So, when we talk of cluster sampling, the geographical aspect of the population is taken into account. So this is a diagram of cluster sampling. Each one of these groups represents a cluster. Okay. So yeah. And these clusters, they are the selected sample. Now this is the second type of sampling, non-probability or random sampling. So what is non-random sampling? It does not give all the individuals in the population equal chances of being selected. So obviously this contradicts probability sampling. In probability sampling, each individual has equal chances of being selected, but not in the case of non-probability sampling. Only some units of the population have a greater chances or unknown chances of being selected. The units are selected at the discretion of the researcher. That means he has the power to decide who gets to be in the sample and who does not get to be in the sample. That is, use of human judgment in selecting units. Very convenient in the situations when the sample to be selected is very small, and the researcher wants to get some idea about the population characteristics in a short amount of time. So this is the first type of non-random sampling. A convenient sample is obtained by selecting population units that are convenient for the investigator to select. That means he gets to choose those units of population which he finds most convenient to obtain. Okay? It is also known as chunk sampling, where a chunk or a part of the population is selected not by probability or judgment but by convenience. So, convenience is all that matters to the researcher. Example, you could pick out 100 people to be surveyed simply from the telephone directory. Why? Because it's convenient to the researcher. So this is how convenience sampling looks like. The researcher selects those units which are convenient to obtain. Okay. Now we have judgment or purposive sampling, which is the second type of non-random sampling. The choice of sampling items depends exclusively on the judgment of the investigator. So, judgment plays the major role in this sampling. The investigator exercises his own judgment and includes those items in the sample which he thinks are most typical of the universe with regard to characteristics under investigation. Also, very, very practical when the investigator is highly skilled and when the decisions have to be made under time constraints and when taking probability samples would be very inconvenient and highly time consuming. Example, if a professor wants to investigate the spending habits of 50 students in his class, he may pick a sample of 10 students who, in his opinion, represent the class. That means the professor is exercising his judgment in selecting the sample of the population, right? So this is what judgment sampling looks like. The researcher gets to choose the units of population by exercising his judgment. That means there definitely is place for bias and partiality. Now we have quota sampling. This is the third type of non-random sampling. It is a type of judgment sampling. The researcher finds and interviews a prescribed number, which is the quota, a prescribed number of people in each of several categories. Okay, so that means a fixed number of units is already given and you have to go by that number. Okay, so quotas are set up according to given criteria. The selection of sample units within the prescribed quota, the quota can be 50, 10% or 1,000 people, is made according to the personal judgment of the investigator. So this is where the judgment sampling element comes into play. Example, if the investigator is sent out to interview 500 persons out of a 2,500 population in a given area with regard to their employment. Okay, the survey is going to be done on employment with a pre-established criterion. So this will be the quota, okay? That out of 500, 20% should be male and 20% should be female. This is the quota. 20% is the quota for male and female. Then the investigator is free to choose the sample items within this quota and conditions. So this is the population of 2,500, out of which 1,500 male and 1,000 female. So the quota sampling, what is the quota? The quota is 20% male and 20% female, right? So based on that criteria, 300 males are to be interviewed and 200 males are to be interviewed. So this is snowball sampling, the fourth type of non-random sampling. It is also known as chain sampling or referral sampling. It is where the research participants recruit other participants for a study. Okay? It is used where potential participants are hard to find. It is called snowball sampling. Why? Because once you have the ball rolling, it picks up more snow along the way and becomes larger and larger. So let's say there is a study, and this study was investigating cheating on exams. Potential participants would be wary to come out. However, existing participants would likely know other people in the same situation and could inform them about the benefits of the study and reassure them of confidentiality. So this is what snowball sampling looks like. As you can see, it has formed chains, and this person is going to form a few more chains. Okay, so this way the researcher can get participants for his study. So we have come to the end of this class, but I would like to draw your attention to this slide. It's very important. Please take a screenshot or maybe jot this down and stick it on your wall. because it's very important to remember these types of sampling and the categories they come under. So in the exam, this is how they'll ask the question. Which one of the following is a type of probability sampling? Okay, so you have to choose which type comes under the category of probability sampling. Judgment sampling, quota sampling, convenience sampling, they all are non-probability sampling. However, systematic sampling is the only probability sampling here. So our answer will be C. Second, which one is not a non-probability sampling? So this is a bit tricky. Which one is not, okay, not a non-probability sampling? So let us first find out non-probability sampling out of these 4 options. Convenience sampling is a non-probability sampling. So is snowball sampling and also quota sampling. So we are left with cluster sampling, which is a probability sampling. So our answer will be D. Cluster sampling is not a non-probability sampling. So just make sure you thoroughly understand these types of sampling and also recognize, which is very important, recognize which type of sampling comes under probability or non-probability. If you found this video useful, then please do not hesitate to press that like button for me. Thank you very much for watching my videos and being patient with me. I'll be back again with more videos. Until then, stay safe, take care, bye.